Hello everyone. In this video, we are going to solve the problem number 1.23 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A point moves rectilinearly with deceleration whose modulus depends on the velocity v of the particle as w is equal to a root b. So the particle A, which is moving rectilinearly, the meaning of saying is that it is moving in a straight line. Okay, and it is moving with the negative acceleration, that is deceleration. So the meaning is that the velocity is in this direction and acceleration will be in this particular direction. Let us denote it as W. Okay, so the velocity will be in the opposite direction of the acceleration, and the expression of the acceleration is given as a root v, and here a is the positive constant. Okay, and at the initial moment the velocity of the point is equal to v naught. So at t is equal to 0, velocity is equal to v naught, and it is asking what distance will it traverse before it stops and what time will it take to cover this particular distance. Let us assume that at t is equal to 0, the particle was at x is equal to x naught, and at the time instant of t is equal to, let us say t, the particle has reached to x is equal to x, and at this particular time instant velocity is equal to 0. So basically it is stopping at this time instant, and at t is equal to 0 the velocity was v naught. Okay, so the acceleration, that is denoting as w, that we can write it as minus dv upon dt because it is decelerating. So we know that if the point is decelerating, that means dv upon dt is negative, and here a root v, a is the positive quantity and root v is also positive. So that's why this whole quantity is positive. So if dv upon dt is negative, then we have to put 1 minus here. So we can write w is equal to minus dv upon dt is equal to a root v. Now this dv upon dt we can write it as dv upon dx into dx upon dt, and this dx upon dt is what, v. So we can write it as v into dv upon dx. Okay, so we can write w is equal to minus dv upon dt or minus v times dv upon dx is equal to a root v. Now the question is when to use what. Let us say if the velocity is a function of x, then we can use this particular expression. If the velocity is a function of time, then we can use this particular expression. So in the first question it is asking to find the distance. So for that we can use this one. So we can write minus v times dv upon dx is equal to a root v. We can take this root v this side, so we can write minus v dv whole divided by root v is equal to a times dx. And now we will integrate both the sides from v is equal to v naught, because at the time instant of t is equal to 0 the velocity is v naught and final velocity is 0 because it is stopping at that time instant, and x is equal to x naught to x. So here we can write minus root v into dv integral v naught to 0 is equal to a times x, x naught to x. And as it is traveling in the straight line, so the delta s can be the both displacement as well as the distance because it is moving rectilinearly. So delta s we can write it as x minus x naught. Okay, so here we will get minus the integration of root v is v to the power half plus 1 divided by half plus 1 from v naught to 0 is equal to a times x minus x naught, and x minus x naught we can write it as the distance or the displacement, and here we will get minus 0 minus v naught to the power 3 by 2 whole divided by 3 by 2 is equal to a into delta s. So here we will get delta s is equal to 2 divided by 3a times v naught to the power 3 by 2. Okay, so this is the value of distance we got. Now, in order to find the total time taken to cover this particular distance, we can use the first expression, that is minus dv by dt is equal to a root v. Okay, so we can write minus dv upon dt is equal to a root v. Again, we can take this root v to this side. We can write dv upon root v is equal to a dt. Now integrate both the sides from v naught to 0 and t is equal to 0 to, let us say, t. So if we integrate left side, we will get minus v to the power half plus minus half plus 1 divided by minus half plus 1 from v naught to 0 is equal to a into t. So here we will get minus 0 minus v naught to the power half divided by half is equal to a into t. So from here we will get t is equal to 2 upon a v naught to the power half. So this is the value of time we got. So the distance we got is equal to 2 upon 3a into v naught to the power 3 by 2, and the time taken to cover this distance is equal to 2 upon a into root v naught. I hope the entire procedure is clear. Thank you.